I am Ken Hellebang, agricultural engineer with the NDSU Extension Service and a professor in the Department of Agricultural and Biological Engineering at North Dakota State University. This presentation will cover the drying and storage of malt barley. The presentation covers both the fundamentals and application of drying and storage. They apply to both on-farm and commercial facilities. The two primary grain storage problems are mold growth and insect infestations. Mold growth is affected by grain moisture content and temperature, so I will focus on those items. The potential for insect infestations is affected by grain temperature and cleanliness around the storage. A grain protectant is recommended if the grain will be held long-term during periods of warm temperatures. Insect infestations frequently start in grain left in the storage or handling equipment. It is critical to thoroughly clean the storages and handling equipment before placing new grain in the storage. It is very difficult to clean under a perforated floor or in an aeration duct. Fumigate these areas if an insect infestation occurred during the previous year. Apply an approved bin spray according to label. To maintain the quality of malting barley, it needs to be at an appropriate moisture content and temperature. The barley moisture content must be low enough to limit mold growth. Molds require a relative humidity of about 70% to grow. The moisture content of the grain that is in equilibrium with air at a given temperature and relative humidity is called the equilibrium moisture content. A relative humidity of 60 to 65% and a temperature of 70 degrees is frequently used to determine the safe storage moisture content of grain. The EMC, or equilibrium moisture content, of barley is 11.8% for air at 70 degrees and 60% relative humidity. The recommended malt barley storage moisture content is 12%. There is a table on my website that lists the equilibrium moisture content for barley at various temperatures and relative humidities. Do a search for North Dakota State University grain drying and storage. The table is in the publications section of the website. Recommended long-term moisture contents permit storing grain at warmer temperatures without grain deterioration due to mold growth. Mold growth starts at about 70% relative humidity. The recommended moisture content is the grain moisture content in equilibrium with air at about 70 degrees and 60% relative humidity. The recommended long-term storage moisture content for barley is 12%. The recommended storage moisture content may be different than the market moisture content. The accuracy of a moisture measurement depends on many factors. The barley in the moisture meter is a small quantity. Is it representative of the grain in the various parts of the field? There is also variability in a truck, with grain separating based on size and density. Moisture meters are affected by grain temperature. Make sure the meter reading adjusts for temperature and that the grain is within the meter's operating range. The moisture measurement is also affected by the physiology of the kernel, which is affected by growing conditions. The measurement will also be affected by kernel damage, changes in test weight, and grain variety. Electronic meters are more affected by the moisture near the kernel surface than internal kernel moisture. They are also affected by condensation on the kernel surface. It is best to place the grain sample in a sealed plastic bag for a period of at least 12 hours to allow the grain temperature to be at room temperature and to provide time for moisture to equalize across the kernel. Then check the moisture content to determine if the meter was fooled. Most electronic meters are not accurate at grain temperatures below 40 degrees, so cold grain should be warmed to room temperature in a sealed container before measuring the grain moisture content. The optimum temperature for mold growth and insect activity is about 80 degrees. Just cooling the grain to 60 degrees greatly reduces the potential for insect infestations and grain spoilage. The allowable storage time, or AST, of commercial grain is affected by both the grain temperature and moisture content. The value in the table is based on the grain temperature being at that value, so the grain must be aerated with air at the desired temperature at least periodically to ensure that it remains at the temperature. Allowable storage time is cumulative. If 1/2 of the allowable storage time is used at a temperature and moisture, there is only 1/2 of the time shown on the chart for the new temperature. For example, if 17% moisture content barley is held at 70 degrees for 30 days, then it is cooled to 50 degrees. The allowable storage time at 50 degrees is 43 days rather than the 130 days shown on the table. The allowable storage time for 80 degrees and 14% moisture is 140 days, which is 20 weeks. The germination may be affected in a shorter time. The allowable storage time of 14% moisture barley at 80 degrees based on germination is only 10 weeks. This is 1/2 of the time shown in the previous chart. Germination may be affected long before there is visible mold growth. The allowable storage time at 12% moisture is 25 weeks. So even at the recommended moisture content, it is important to cool the barley. Cooling the barley to 70 degrees extends the allowable storage time to 60 weeks. Cracked, broken, and immature grain spoils much easier than sound kernels. Therefore, the allowable storage time will be less if the kernels are damaged. Each variety has a slightly different storage life, so allowable storage times in tables should be considered as estimates. Foreign material tends to accumulate in the center of a bin. Barley should be cleaned and a distributor used when filling a bin if there is a higher amount of foreign material in the grain. A distributor assists with leveling the top of the grain. Grain needs to be cooled as average outdoor temperatures cool to limit moisture migration. Air near the bin wall will cool, sinking to the bottom of the bin. This pushes air in the center of the grain vertically. When this air is cooled near the top surface, moisture is deposited on the grain. This can increase the grain moisture content by 10 percentage points or more and lead to storage problems. Moisture migration is limited by cooling the grain when average outdoor temperatures are 10 to 15 degrees cooler than the grain temperature. Grain will stay warm, creating an environment conducive to insect infestation unless it is cooled by aeration. Grain is both a good insulation and heat sink, so it will stay warm even when outdoor temperatures are frigid. Moisture migration during spring and summer only slightly increases the grain moisture content. Convection currents pull air into the top center of the grain, but the moisture content will only increase by a fraction of a percentage point at a depth of 2 to 4 feet below the top surface. Keeping the grain cool limits insect infestations and enhances storage life. Warming the grain would increase the moisture content of all of the grain. The recommended practice is to cool the barley whenever average outdoor temperatures are 10 to 15 degrees cooler than the grain. Cool the grain to either just below 30 degrees for winter storage for northern regions and below 40 degrees for southern regions. Aeration fans can be operated in late winter or very early spring, so the grain temperature is between 30 to 40 degrees going into spring and summer. Do not warm the grain above 40 degrees. The aeration system needs to be designed to provide the appropriate quantity and distribution of airflow. The distance between aeration ducts should be no more than the grain depth, and the distance between air distribution point and the wall should not exceed 1/2 of the grain depth. To obtain an acceptable airflow distribution for natural air drying, the ducts are spaced at 1/2 and 1/4 the grain depth. All components of the air handling system need to be properly sized. The Dry Grain Aeration Systems Design Handbook, MWPS 29, includes guidelines for evaluating, sizing, and locating all components of an aeration system. Do an online search for MWPS. Airflow distribution will not be uniform using ducts. This figure shows that air takes the path of least resistance. Locations above and between ducts need to be checked to determine when grain cooling or drying has been completed. A perforated floor with a level top grain surface will provide the most uniform airflow. Peak grain in the top of the bin should be removed and the top surface leveled. Since air takes the path of least resistance, air will go near the bin wall and there will be little airflow through peak grain. In addition, peak grain will warm much more rapidly during spring and summer. Also, during the fall and early winter, if moisture migration occurs, more moisture will accumulate in cool grain in the peak. Aeration cooling time can be estimated by dividing the number 15 by the airflow rate in CFM per bushel and adjusting for test weight. For example, an aeration airflow rate of 0.2 CFM per bushel will cool a bin of barley in about 65 hours. Dry grain in storage at 70 degrees or cooler does not need to be cooled quickly, so an aeration airflow should be selected that does not require a large horsepower fan. For example, a 3 horsepower axial fan will cool a 42-foot diameter bin of barley 24 feet deep in about 68 hours. Aeration is an extremely good investment. Operating the aeration system for 6 cycles during the year will only cost about 1/2 cent per bushel for insect and mold protection. Fans should be turned off during extended periods of snow, rain, and fog to prevent the moisture being blown into the bin. A few hours of operation during a rain shower is not a concern, but operating the fan for many hours during fog or rain will move moisture into the bottom of the bin. Only the grain at the bottom of the bin will be wet if the fan is operated for a day during rain or fog. Normally, cooling grain with aeration will reduce the grain moisture content by about 1/4 to 1/3 percentage point. A bin roof may be damaged when vents become sealed with frost or ice during aeration. It is recommended to leave a fill hole and/or access door open or close them with elastic straps so they can act as a pressure relief valve to prevent damage to the bin roof during fan operation when outdoor temperatures are near or below freezing. Aeration fans should be covered when not being used to prevent grain from being warmed in the spring and summer. Wind blowing into an uncovered fan will warm the grain to near the average daily maximum temperature. Covering the fan also keeps out snow, pests, and warm, humid spring air. Stored grain should be checked every 2 weeks until it has been cooled for winter storage, every 2 to 4 weeks during the winter, and every 2 weeks again during spring and summer. Measure and record the grain temperature and moisture content. Increasing grain temperature and/or moisture content indicates storage problems. Observe the grain for any insect activity. Grain temperature cables are an excellent tool for monitoring grain temperature. However, since grain is an excellent insulator, the sensor only detects the temperature of the grain next to the sensor. A hot spot only a few feet from the sensor will not be detected. The temperature cable should be used as a tool to monitor the stored grain, but does not replace physical observations, probing the grain, checking the moisture content, and other normal procedures. Several companies market grain temperature monitors and fan controllers. Again, they are tools that assist with grain storage management, but do not replace needing to understand proper management practices and on-site observation and management. Additional tools are now available to assist with managing the stored grain. One senses insects drawn to a probe, and the other measures the carbon dioxide level. Both insect infestations and grain spoilage produce carbon dioxide, so monitoring the concentration assists with detecting problems. In addition to the outdoor temperature increasing during late winter and early spring, solar energy will warm grain at the top of the bin and near the bin wall above the average outdoor temperature. The amount of solarization on the south wall of the bin on February 21 is more than double the amount on the south wall on June 21. It is important to monitor the barley and periodically aerate to cool the stored grain during the spring. Solar heat gain on the roof can warm the barley at the top of the bin. Ventilate the top of the bin similar to an attic by providing air inlets at the eaves and air outlets at the peak. Another option is to install a fan in the bin roof that is controlled by the temperature at the top of the bin. The top portion of a bin of grain stored during the summer will warm due to the solar heat gain on the roof and warm outside temperatures. This warm grain will be more prone to insect infestations, so the aeration fan should be operated periodically for a few hours during a cool morning to cool the barley at the top of the bin. The aeration fan should push air up through the grain to use the cool grain near the bottom of the bin to cool the barley near the top of the bin. The fan should only be operated enough to cool the barley near the top of the bin while limiting the amount of grain warmed near the bottom of the bin. Barley is frequently harvested at moisture contents exceeding the 12% desired for storage. Natural air and low temperature drying is frequently used to dry the barley. With natural air drying, a drying zone gradually moves from the bottom of the bin to the top, with the grain below the drying zone being in equilibrium with the air, and the barley at the top staying at the harvest moisture until the drying zone has reached the top of the bin. The drying fan should be operated continuously. The daytime and nighttime conditions are buffered in the zone at the bottom of the bin, so the grain dries based on the average air condition. The fan contributes heat, which will reduce the air relative humidity and the grain moisture content. To estimate the final grain moisture content, determine the average temperature and relative humidity for your location. For this location, the average August temperature is about 68 degrees, and the average relative humidity is about 65%. Using the equilibrium moisture content chart, the barley is expected to dry to about 12.5% for 68 degrees and 65% relative humidity. However, due to the fan heat, the final moisture content will be closer to 11 to 11.5%. If the air relative humidity is high, the barley will not dry to the desired 12% moisture content, regardless of how long the fan is operated. For air at 70 degrees and 75% relative humidity, the barley equilibrium moisture content is 14.1%. So that will be the moisture content of the barley. Warming the air just 5 degrees with a heater reduces the air relative humidity to 63% and the barley moisture content to 12.1%. Rarely does the air need to be heated more than 5 degrees. Warming the air more than 5 degrees would result in the barley moisture content being lower than desired. Natural air drying times can be estimated from the wheat drying table in the NDSU publication EB35, Natural Air Low Temperature Crop Drying. Since barley weighs less than wheat, there is less water that needs to be removed. Wheat at 17% moisture can be dried using an airflow rate of 0.75 CFM per bushel in about 31 days. The estimated drying time for barley would be 80% of that time, which is about 25 days. However, the allowable storage time of malt barley is 25 days to maintain germination. There would be less probability of germination loss by increasing the airflow rate or not air drying barley exceeding 16% moisture content using an airflow rate of 3/4 of a CFM per bushel. The time required to natural air dry wheat from 17% to 13% increases as outdoor temperatures cool. Normally, air is heated about 3 to 5 degrees as it passes through the fan. Listed in this table is the North Dakota monthly average temperature and relative humidity. The temperature and relative humidity of the air after being warmed 3 degrees by the fan, the expected final wheat moisture content, the number of days required to dry the wheat, and the percentage increase in drying time compared to the time to dry in August. For example, it is expected to take 31 days to dry the wheat in September using an airflow rate of 3/4 of a CFM per bushel, which is 20% longer than the 26 days expected in August. At temperatures near or below freezing, the drying times become excessive. Grain drying should not be expected at temperatures below freezing. This would also apply to barley. Mixing dry and wet barley does not equal storage at the average moisture content. Moving air through the mixed barley will aid in obtaining a uniform moisture content, but some of the wet barley will exceed 12% moisture. Germination loss occurs to individual kernels based on its moisture content and temperature. There may be a loss in germination even though the average moisture content is at the recommended 12%. Proper fan selection is critical to obtain the required airflow. A rule of thumb for natural air drying of 1 horsepower per 1,000 bushels only applies for a barley depth of 20 feet. Greater depths are discouraged due to the fan horsepower requirements becoming excessive. Use a fan selection program such as the University of Minnesota program that is available online to select a fan or determine the expected airflow of an existing fan. This website is linked from the NDSU Grain Drying and Storage website. Newer dryers have features such as grain turners, tapered columns, and electronic controls that permit more gentle and efficient drying. Consider a dryer with these features when selecting a high-temperature dryer. Germination is affected at kernel temperatures of about 120 degrees. So normally 110 degrees is the recommended maximum dryer temperature to limit the potential for impacting germination. Bridging of grain in a bin transfers more of the load to the bin wall that may lead to bin failure. Follow recommended storage management practices to minimize the potential for crusting or bridging, and watch for the grain flow when unloading. Never enter a bin while unloading grain. Also, do not enter a bin to break up bridged grain. Moldy grain is a health hazard. Wear a mask rated to remove mold spores when handling grain. Normally, they will have an N95 or N99 rating and be held in place by 2 straps. Ice accumulation on fans leads to imbalance and vibration. Monitor fans for ice accumulation and remove the ice if it is observed. More information is available online. Do a search for NDSU Grain Drying and Storage.